for this particular pest. I'd like to invite Dr. Belinda Luke from Cabby Europe in the UK to please take the podium.
Good morning. So today I'm going to be talking about something very different. I'm not looking at the whole supply chain, I'm just looking at storage. Now in the results I'm going to present to you, that's storage for small-scale farmers, but it can be used in any storage. It can be used in large grain stores, farm storage, village storage, anything like that. Oh, that seems to have gone too fast. So I'm going to be talking about biopesticides, which hasn't been talked about, as far as I'm aware, at this conference yet. And this work is done in collaboration with two commercial companies, Exosex and Agroxine. And we're going to be looking at controlling the larger grain borer, this beautiful beast here, with a fungus called Bavaria bassiana, which is this one here. So just to give an overview of my presentation, I'll briefly tell you a little bit about Cabby. Then I'll give you the history of Bavaria and where the project came from. And then I will give you just 2 bits of information from all the field work we've done. Please read my abstract if you'd like more information, because I can't fit it into the 15 minutes. And within that information that I'll be giving you is we're talking about the storage trials that we did and how we proved that the Bavaria can control the Prostephanus. So Cabby is a not-for-profit organisation, and we're all owned by 48 member countries. We're in 21 different locations globally, and there's about 400 staff, so we're a relatively small organisation. But within that organisation, we have 2 different fields. We have international development, where we carry out research and implementation within the field. And then we also have our publishing side, which does Cabby Books, which some of you may know, and Cabby Abstract. And Cabby is the largest abstractor of agricultural information. So what's the problem? Well, we know what the problem is because we've been talking about it for the last 2 days. But in particular, for the larger grain borer, you have your maize right at the top there. And then the next one down, you have the larger grain borer, comes along, causes damage. And then the bottom picture is what the farmer's left with. So instead of nice maize that they can then cook to feed their families or to sell at market, they're left with a bag of useless dust. So we're using this fungus called Bavaria bassiana. Now the Chinese noted it in 3000 BC, so it's been around a long time. They didn't know what it was, they didn't know what it was called, but all they knew is that it was making their silkworm populations crash. And it wasn't until 1934 that, ironically, an Italian, Agostino Bassi, spent 25 years of his life working with the French and the Italian silkworm industry to find out what was causing the disease. And he discovered that, and in honor of his work, they named the Bavaria bassiana after him. So he discovered what the fungus was, how it was infecting the insect, and the life cycle that was going on. And today, there are very successful products in the market. For example, Naturalis to control whitefly, very popular. And safety-wise, that's very important, and lots of work has been done on this. There was a very good review by Zimmerman in 2007 that basically concluded it is not harmful to the environment, it is not harmful to animals, and it's more importantly not harmful to humans. So we had a project within the UK looking at UK storage pests. On average, we store about 25 million tonnes of cereals within the UK, but lots of the active ingredients are being banned by the EU. There are very few alternatives. So we said, well, okay, we can produce a biopesticide that will be safe for the environment, that will control the product. And we had a very successful research program, and now it is in commercialization, and Exosex are taking that forward. So on that evidence of it working in the UK, the Bill and Melinda Gates Foundation approached Exosex and said, well, this is really interesting stuff. Will it work in Africa? And we said, well, this is a UK isolate for temperate climates. We know it kills Prostephanus. We tested that in the labs. but whether it works in the environmental climate of Africa, we're not sure. So we applied for a grant. We were very fortunate, and we received a two-year proof of concept project. And we based it in Ghana and Tanzania so that we had East and Western Africa environmental conditions. So this is just the very first test we did. Does it kill LGB? So we can see here, after 14 days, 100% LGB in both countries, in Ghana and in Tanzania. Now, obviously, storage pests don't just come along by themselves. It's a complex of pests, and the second most popular one to damage maize is Cytophilus, so we also tested it on Cytophilus. And again, 100% at 14 days in Ghana, and above 90% in Tanzania. We did an additional test in Tanzania, because they mass produce and they mass release a predator of the larger game borer called Turrittius nigrescens, TN on this graph here. And the Ghanaians were very concerned. It's like, well, hold on a minute. If this fungus kills storage pests, is it going to kill our biocontrol agent? We don't want to kill our natural predator. So we did a test on that, and as you can see, there was 30% kill. So not a great amount of kill. And also, it's being used in a different way. The Turrittius is being released into the field. It's not in the storage. It's not being put into storage bags. We are putting our product into storage bags. So in theory, they're not going to cross over, but we had to assure the Ghanaians that this was not a problem. They're investing a lot of money in the mass production of Turrittius. Sorry, I keep on clicking too quickly. So then we carried out various experiments in between, and then the last experiments we carried out, which I'd like to talk about, is the semi-storage trials. And what I mean by semi is that we added insects. It wasn't natural infestation. But all the environmental climates and conditions were exactly the same as you would have in your in sub-Saharan Africa. We had 2 locations with Ghana and 3 in Tanzania. And then we had 3 treatments, a control, nothing added, and 2 treatments of Bavaria, a high and a low. We added 100 insects to 2 kilograms of maize, and then for each treatment and for each time, we had 8 bags, 8 replicates. And we destructively sampled at 2, 4, 8, and 12 weeks. What do I mean by destructively sampled? So at week 2, we would go and we would take 8 bags from the control, 8 bags from the low concentration of Bavaria, and 8 bags from the high concentration of Bavaria. We would sieve it, we would get grain weight, we would get dust weight, we would get number of insects alive and dead. So these are the sites in Tanzania. So we have from the north up in Arusha, we had in Dar, representing the eastern side, and then the central zone was Mbeya. Now, the central zone is right on the outskirts of where you would expect to find LGB. That's the cooler of the regions. Sorry, I do apologize. And then Arusha is the next one in climate-wise, and the hottest region is in Dar. And in Ghana, again, we wanted to look at different ecological zones, so we looked at the north and we looked at the south. So here are our results. A little bit scary, but I'll talk you through it. So on the left-hand side, we have our Ghana field sites, and on the right-hand side, we have our Tanzania field sites. For those of you who are paying attention, I said we had 3 sites in Tanzania, and there's only 2 sets of data there. Unfortunately, we had issues with the insects that were being supplied, so we had very high control mortality, and those results were not valid. So what we can see here is that we're getting very high control, 90% in all treatments. However, what we also noticed is that, especially in Ghana, this was more obvious, and the climate there is hotter, we were noticing after 8 weeks a drop in percentage mortality. And I say percentage mortality because what was happening is the larger grain borer's life cycle is approximately 6 to 8 weeks. So what we were finding is when we were sampling the 8-week samples is there was a huge spike in the actual population of LGB present. But what does this mean to the farmer? Very little. This is what the farmer is interested in. So this is the powder weight, the amount of damage that is caused by the LGB. So we can see here, week 2, week 4, there's not much damage. Come week 8, you're starting to see damage. But by week 12, by putting our Bavaria product in, you are saving more than 50% of your product. That farmer has 50% more maize that he can feed his family with. So what are the next steps? Well, we need to strengthen our data package. We only ran storage pests for 12 weeks. We only saw one cycle of LGB. We need to know what the population dynamics are going to do. So we need to run the trials for longer. And we need to extend our countries that we're doing it in. We've done Eastern, we've done Western, but we haven't done Southern Africa. Now, in Southern Africa, they only have one harvest a year. So they are going to be storing it longer. We need to do tests in those countries. And also as well, that's very good as scientists going in, but we need to give our product to the farmers. We need to say, okay, apply this product. Let's look at natural infestation, which is very hard to quantify when you come to do stats. Tell us what happens. So we need to get it out there to the farmers as well. Now, with any product, it has to be at the right price for the farmer or they're not going to buy it. So we need to look at refining costs. And for example, our formulation, we chose a formulation at the beginning of the 2 years and we stuck with that. Now, Exocet have been doing work outside of this project on formulation and already have developed a cheaper formulation. So there are improvements like that that can be done. Targets. Well, there are a range of storage pests, and this isolate is effective against most of them, including mites and including moths. So it doesn't have to be LGB. It can be pretty much any storage pest. And also, it doesn't have to be maize. It can be cassava, is another crop that is devastated by LGB. We can put it in cassava, we can put it in cocoa, we can put it in any storage system. And obviously commercialization. Now this is something that CABI doesn't do. We do the research, but we don't commercialize. And that's why we work with commercial companies, so that we have an end product in sight. So we need to do more work on that. Your routes to market. How are you going to explain this new, relatively new technology to the farmers? All this would be encompassed within the next steps. So just to summarize, we can kill larger grain borer and we can kill Cytophilus in African environmental conditions in the east and the west of Africa. And our storage trials have been really successful for first-time trials. We were pleasantly surprised, at how good they were. And we've got a clear vision of where we'd like to proceed with this. We don't have funding to do it yet, but we do have a clear vision of where we'd like to go. Thank you.
Okay, we have time for a few questions.
Thanks. Nice presentation, Belinda. Anson Ward, I'm doing some work with the Serve Food Initiative with FAO. Do you think this product could be applicable to fish, dried fish, and the insect pests which affect that product?
Yeah, the actual product that you're trying to save doesn't matter. It's the actual storage pest that we can control. So, excuse me, I don't know what the major pest of dried fish is. Is it?
Domestes species, maculatus?
Okay, yeah, I'm pretty sure we've tested that within the UK, obviously not within Africa, and we do get good control.
There was a question down here.
Thanks for sharing this information. My question is, anytime you add something to grain for protection, whether it's natural product, biopesticide, or other protectant, there's in many places regulatory requirements, particularly if you're trying to get the product also to market. And of course, a lot of discussion have been getting smallholders into the value chain versus just for their own sustainability. Is there anything with this product that has to be considered in terms of regulatory approval in any of the countries that you're aiming at?
Yeah, well, because it's going through regulation in Europe at the moment, there's an eco-tox package done on it, so we know that it's safe. And the quantities that we're adding are very tiny. So if anybody's a cook out there, we're adding less than 1/4 of a teaspoon to a kilogram of maize. So we're adding very small amount. And also, cooking is going to kill the spores if there's any spores, within that. That's not washed off when they wash the maize.
There was a question here in the front. Yeah? Hang on, here comes a microphone.
Thank you. Thank you. How were you measuring the loss? Were you doing dry weight loss? Exactly.
Yeah, that was the weight of powder that was extracted after we sieved the maize. Does that answer your question? No.
Okay, thank you very much. That's great.